So now we're going to take a look at another series of questions. Let's see. These deal with vectors. So one of the questions that I've got here, it's a two-parter. It says a truck travels up a hill with a 9-degree incline. The truck has a constant speed of 15 meters per second. What is the horizontal component of the truck's velocity? In other words, speed. In the next section we're going to talk about the important differences between speed and velocity. For us, we're going to be going through and playing around with this. Right now, we just need to know that we've got something like this. We've got a truck that is going uphill. And it has a speed, or I guess I could say velocity since I know the direction, but it has a speed of 15 meters per second. That's how fast it's going up the hill. Now they want us to take this velocity. It's a velocity if we take the magnitude, 15 meters per second, and the direction, 9 degrees uphill above the horizontal. That's a vector because it has both a magnitude and a direction. If we just talk about 15 meters per second and not the direction, then it is a speed. That's a preview of things to come. All right, they want us to take this velocity and split it into its components. So we've got a velocity vector that looks like this. 15 meters per second, 9 degrees. There is an x component here. We'll call that vx. And there's a y component here, vy. Now we did this primarily in class with distances, but we're going to find that there's a bunch of stuff that's actually vectors. One of them is going to be a velocity. In fact, this is something we're going to be doing a lot in the near future. All right, we basically have a triangle here, and we can do what we've done many times before, SOHCAHTOA. Now, if we want the x component, which I believe is what is asked for first, the horizontal component. Now, we don't always say x component. A lot of times we'll say horizontal, or you may even see the terminology parallel to the ground. These are all ways of saying the same thing. An important part about physics is being able to understand what's being asked of you without it being in a robotic, always the same way kind of approach. Physics is about applying math to the real world. So I want to try and talk like regular people. So we're going to find the horizontal part, that's the x component. Okay, well if my angle is 9 degrees, I've got a triangle here. I know the hypotenuse, I know my angle, so I'm going to use one of these. But I want to use one that has the hypotenuse, so either SO or CA. Now here, I can identify which one I want, because if I want the x component, and this is my angle, it's the adjacent side, which means we're going to use CA. CA tells us that cosine of theta equals the adjacent, words are hard, adjacent over the hypotenuse. Never hurts to write this out, just a recommendation. Now we can fill in our actual numbers. Cosine of 9 degrees equals the adjacent, which is Vx. I don't know that, but that's what I'm solving for, over my hypotenuse, which is 15 meters per second. I can solve for Vx by getting it by itself, multiply by 15 meters per second, multiply by 15 meters per second. Got to do the same thing to both sides. You'll see that these cancel out, leaving me with just Vx. Now I can turn to my calculator. Make certain it's in degree mode with the mode button and that it's highlighting degree. And second mode, that usually clears it out. I'm in degree. If you're in radian, you'll get a crazy town banana pants answer. All right, cosine 9 degrees are my numbers. That gives me 0.9876, etc. I'm just going to multiply that by 15 for 15 meters per second. Now remember, cosine of an angle, it takes an angle and gives you a number with no units. So the units are going to be determined by whatever we multiply this with. So we end up with the following, that Vx is going to be equal to 14.82, because I've got 815, but we'll call it 14.8 to 3 significant figures, meters per second. Let's double check our answer here. 14.8 meters per second. And the second part of this question, as you might have guessed, is going to be, what is Vy? Well, in this case, the y component is going to be my opposite side, so we're going to do so. So part 2 is going to be basically what we did in part 1, except this time it is sine of theta equals opposite over hypotenuse. Well, if I write this out, we've got sine of 9 degrees equals Vy, my opposite side in this case, divided by 15 meters per second. I'm going to multiply by 15 meters per second, just like we did before to get Vy by itself. Got to do the same thing to both sides. And now, sine of 9 degrees times 15, done. We end up with Vy is equal to 2.346, so I'm going to round that to 2.35 meters per second. Double check our answer. 2.35 meters per second. They've got 2.34652, which is the actual value here. But this is perfectly fine. The computer will identify that as the correct answer. Like I said, 3 significant figures is what we're doing for class. All right?